CardLine Software has been created by CardGio Corporation. It consists of two services. First is the processing and interpretation of the MIT and MTT data. Second is the visualization of any kind of wireline data. Our company can also process the MIT data for pipeline deformation analysis, also known as PDA. In this video, we describe how to work with the interpretation of the MIT and MTT data. First, we should convert the LAS data into a binary CGF file. Second, we run the MIT data processing. We should then assign zones with different casing weights and sizes. Our table for all possible casing grades will assist you. Then, we should assign the primary and secondary methods for calculating penetration. It could be nominal, elliptical, or mode ID. By clicking this button, we should set up the curves which will be included in the final joint summary. They could be metal loss, ovalization, eccentricity, mean diameter, and others. Then click OK. First, you should run the centralization. When we run centralization, the program will calculate the eccentricity curve. You can see it here. Eccentricity is equal to the value of the distance for which the center has been moved from its original position while the cross-section is centralized. Next, we run filtering. To recall 3D view, we click on the 3D view button. By clicking the Enter button, we can switch between vertical and edge view. The edge view could be displayed with arms numbers, arms radius, or percent penetration. Double-click on the main log to recall cross-section window. If you drag the left mouse, you can see the cross-section for the current depth. The current cross-section, main log, and 3D view could be saved as a snapshot if you click the Save Bitmap button. The snapshot will be saved in the data directory. We can switch the view between the centralized and non-centralized data. This view will then be simultaneously switched for the main log, the 3D view, and the cross-section. After closing the current session, or if the program crashes, you can easily restore the previous session by clicking on this Restore Session icon. The previous session will then be restored at the same depth interval for the main log, 3D view, and cross-section. At no point will you lose any of the work that you have done in the previous session. The Express Joint Summary is a very powerful tool which helps you find joints which have the highest deformation, ovality, corrosion, or penetration. The Express Joint Summary consists of joints with parameters such as joint length, class of corrosion, percent of penetration, ovalization, and eccentricity. By clicking on the header of any of these parameters, for example ovalization, we will sort all joints by ovalization. If you want to go to one of these joints, you simply click on the joint number and the program will immediately jump to this joint in the main log, cross-section, and also in 3D view. If you want to find the most deformed joint, you can sort by eccentricity. Click on the joint number in the joint summary and automatically go to the problem joint and see the extent of the deformation. You can then create a hard copy of any joint by clicking the right mouse and then selecting the Creating 3D Printer STL model. Here we can assign the exaggeration parameter, for example that of a coefficient of 3. You can now print this model on a 3D printer. The corresponding STL file is saved in the data directory. Editing color position. The program automatically finds all colors within the well. But sometimes some colors could be missed or may be in a wrong position. We can then add a color, move it, or remove it completely. This edited information will immediately be reflected in a joint summary. CardLine creates a joint summary as a CSV file in a data directory. This joint summary could then be included in the final PDF report. If some finger is stuck or malfunctioning, you could easily fix that finger. If you hover the mouse over a specific arm, the software will show you that arm's number at the bottom of the screen. For example, when we hover the mouse, we find that this broken arm number is 23. If you then go to the cross section and click here, you will see that this arm number is 23. Click Process, then Bad Finger, and assign finger number as 23. At depth interval of 440 meters to 460 meters. Then click OK, and the problem is resolved. Editing color palette. You can edit the color palette by clicking the right mouse and select Menu Command. Changed color palette will be reflected in both main view and the 3D view. We can remove slide, add slide, move it to another position, or change color for this slide. For example, this is how you can assign a white color to this slide. You can also change the scale values for each slide. Any customer could create his own color palette. After editing the color palette, you can save this created color palette as a template. As well, you can import an external file of a previously saved color palette. You can also save an edited color palette as a default palette for all future projects. Viewing curves and depth by dragging the mouse. If you click and drag the left mouse, you can see all curve values in the well header. Also, in depth track header, you can see the current depth. This is the end of the first part of our demo.